Okay, let's find the equations of direct variations, inverse variations, and joint variations. Just a quick reminder that anytime you hear the word direct variation, you're thinking multiplication. Anytime you hear the word inverse variation, we're thinking division. Okay, so in the first problem, it says y varies directly as x. So if y varies directly as x, we're going to have some constant of variation, some k value that we can multiply x by to give me y. So there's your equation. And just like a line or any other equation, in order to find that k value, we're just plugging in. It says if y is 12 when x is 3. Plug those values in. If y is 12 when x is 3, divide by 3, and we have a k value of 4. So therefore, now that we know what our k value is, we know that y equals 4x. There's your direct variation equation. It says now, find the value of y when x is 7. So just plug in 7. So if we plug in 7, we get a y value of 28. Now, I do want to tell you that anytime you have a direct variation, that it is proportional. And that you can solve direct variations with proportions. There will be a constant of variation. There will be a direct variation equation, all this. But look how I solve this. Y varies directly as x. That means it's proportional. If y is 12 when x is 3, what is the value of y when x is 7? If you don't remember proportions, we can multiply these two things together. That gives you 84. We divide by the other number, and that gives you a value of 28 as well. Next one says y varies inversely as x. That's going to be y equals k over x. Inverse variation. Then they give you an example, y is 6 when x is 4. To solve this, to figure out your constant, we're simply going to multiply by 4, and that gives me a constant of variation of 24. So let's go back and just simply change that. So there's my inverse variation equation. Now, they're not proportional. Be careful. What is the value of y? So now we're looking for our y value when x is 3. So all we're doing is plugging in a 3 for x. And when we plug in a 3 for x, we get a y value of 8. That's it. Joint variations, same thing as direct variations, except for you're going to have more than two variables. Z varies jointly, meaning that all together, as with x and y. So it's a direct variation with multiple variables. Then they're going to give you a scenario. Z is negative 48. We don't know the constant. That's what we're looking for. When x is 4 and y is negative 3. When x is 4 and y is negative 3. When you multiply that, that gives you negative 12. We're going to divide by that to find your constant, and that gives you a constant of variation of 4. So I'm going to rewrite this. So z equals 4xy. That's your variation equation, your joint variation equation. Then they're going to say what is, and I believe I misspelled there, what is the value of z when x is negative 2 and y is 7? So we're looking for, you can write it as z of negative 2, 7 is what we're looking for. So you're going to do 4 times negative 2 times negative 7, which gives you a value of 56. Okay, let's do a few more. Y varies directly as x, so y varies directly as x, but then it says inversely as z. So you can have multiples mixed in the same problem. And then they give you a scenario. Y is 10. We don't know the k. When x is 5 and z is 3. So we've just got a little bit tougher equation to solve. We're going to multiply by 3. That gives me 30 equals k times 5. Divide by 5, and we get a k value of 6. So it's going to be 6x over z. There's my variation equation. And then it goes on to say, what is the value of y when x is 8? So x is 8 and z is 4. That's going to be 48 divided by 4, or 12 is your answer. Z varies directly as x and inversely as the square root of y. Directly as x, that means multiply. Inversely as the square root of y. They give you a scenario. Z is 12 when x is 3 and y is 4. So the square root of 4 on bottom would just be a 2. Multiply by 2 gives you 24 equals k times 3. So obviously k is 8. So I'm going to go back over here and put 8x over the square root of y. There's your variation equation. What is the value of z now when x is 5? So it's going to be 8 times 5 on top, and y is 25. So the square root of 25 is 5, so those will actually cancel and gives you a z value of 8. And the last one, d varies directly, that's multiplication, as the square of t. And several things have this type of direct variation. D varies directly as the square of t, not square root. Be careful there. If d is 64, let's look for that k value. If d is 64 when t is 2, so it's going to be k times 4, divide by 4, that gives you a k value of 16. So d equals 16t squared is your equation. Then they're going to give you the scenario. Find d when t is 5. So again, what we're looking for is d of 5. That's going to be 16 times 5 squared, which is going to be a total of 400.